Internet Mail implementation class layer in Jakarta Mail. Focusing on Internet Mail implementation class layer. The Internet implementation layer implements part of the abstract layer using Internet standards RFC 822 and MIME. Here you can see a MIME message, MIME message object hierarchy. Here the message, you can see the message here and message here. Get from method returns address of message sender. Get subject method returns message subject. Get content type method return for example multipart / mixed. In message get content method return multipart. Multipart consists text, image, multipart. Here in text get count returns for example 3, and in multipart get body part returns body parts. You can see body part here, and in body parts get content type returns for example text plain, and here get content returns message text here. Here get data handler returns data handler. Use the data handler methods to access the image. Here get content multipart returns here multipart, and get content returns multipart. Repeat with multipart as before. Here you can see the class hierarchy of main classes in Internet Mail. The Jakarta Mail specification does not define any implementation. However, the API does include a set of classes that implement the Internet Mail standards. Although not part of the specification, these classes can be considered part of the Jakarta Mail package. They show how to adapt an existing messaging architecture to the Jakarta Mail framework. These classes implement the Internet Mail standards defined by the RFCs listed below. RFC 822, the standard for the format of Internet text messages. RFC 2045, RFC 2046, RFC 2047 MIME. RFC 822 describes the structure of the message exchange across the Internet. Messages are viewed as having a header and content. The header is composed of a set of standard and optional header fields. The header is separated from the content by a blank line. The RFC specifies the syntax for all header fields and the semantics of the standard header fields. It does not, however, impose any structure on the message content. The MIME RFC 2045, 2046, 2047 defines message content structure by defining the structured body parts. By a typing mechanism for identifying different media types, and set of encoding scheme to encode data into mail safe characters. The Internet Mail package allows a client to create, use, and send messages conforming to standards listed before. It gives the service providers a set of base classes and utilities they can use to implement stores and transports that use Internet Mail protocols. The Jakarta Mail MIME part interface models and entity as defined in RFC 2045 section 2.4. MIME part extend Jakarta mail part interface to add the MIME specific method and semantics. The MIME message and MIME body part classes implement the MIME part interface. The following figure shows the class hierarchy of these classes. The class message in package jakarta.mail in module jakarta.mail. This class models an email message. This is an abstract class. Subclasses provide actual implementations. Interface MIME part in package jakarta.mail.internet in module jakarta.mail. The MIME part interface models an entity as defined by MIME RFC 2045 section 2.4. Class MIME message in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME style email message. It implements the message abstract class and the MIME part interface. Class body part in package jakarta.mail in module jakarta.mail. This class models a part that is contained within a multipart. This is an abstract class. Subclasses provide actual implementations. Interface MIME part in package jakarta.mail.internet in module jakarta.mail. The MIME part models an entity as defined by MIME RFC 2045 section 2.4. Class MIME body part in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME body part. It implements the body part abstract class and the MIME part interface. MIME parts are contained in MIME multipart objects. Here the MIME message implements MIME part. Here the MIME body part implements MIME part. MIME message extends message. MIME body part extends body part. As an example, we can consider this package jakarta.mail.internet. Classes specific to internet mail systems. This package supports features that are specific to internet mail systems based on the MIME standard RFC 2045, RFC 2046 and RFC 2047. The IM, AP, SMTP and POP3 protocols use MIME messages. As example 2, we can consider this code segment. Here the class MIME message. This class represents the MIME style email message. It implements the message abstract class and the MIME part interface. This is in the module jakarta.mail and this in the package jakarta.mail.internet. Here in green color you can see the segments mainly related to the internet mail implementation class layer. As an example 3, we can consider this property mail.fetch Here the property mail dot mime dot address dot strict. The mail dot mime dot address dot strict session property controls the passing of address headers. By default, strict passing of address headers is done. If the property is set to false, strict passing is not done, and many illegal addresses that sometimes occur in real messages are allowed. The type of the property is Boolean. Now we are considering the MIME message class. This code sample creates a new MIME message for sending new MIME message object for sending. The class MIME message in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME style email message. It implements the message abstract class and the MIME part interface. The MIME message class extends the message and implements MIME part. This class implements an email message that conforms to the RFC 822 and MIME standards. The MIME message class provides the default constructor that creates an empty MIME message object. The client can fill the message later by invoking a pass method on an RFC 822 input stream. Note that pass method is protected so that only this class and its subclasses can use this method. Service providers implementing lightweight message objects that are filled in on demand can generate appropriate byte stream and invoke the pass method when a component is requested from a message. Service provider can provide a separate byte stream for the message body distinct from the message headers can override get content stream method. The client can also use the default constructor to create new MIME message object for sending. The client set appropriate attributes and headers insert content into the message object. And finally calls the send method for that MIME message object. This code sample create a new MIME message object for sending. The MIME message class also provide a constructor that uses an input stream to instantiate itself. The constructor internally invokes a pass method to fill in the message. The input stream object is left positioned at the end of the message body. The MIME message implements the write to method by writing an RFC 822 formatted byte stream to its headers and body. First, the MIME message object writes to its headers, then it delegates the rest of the data handler object representing the content. Set from set to set content, send message, a stream of mail messages, reached end of message stream. Now we are considering the MIME body part class. The MIME body part class extends body part and implements the MIME part interface. The class MIME body part in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME body part. It implements the body part abstract class and the MIME part interface. MIME body parts are contained in MIME part objects. MIME body part class extend body part and implements the MIME part interface. This class represents a part inside a multi-part. MIME body part implements a body part as defined by RFC 2045 section 2.5. The get body part index returns the MIME body part object at the given index. MIME part also allows the client to fetch MIME body part object based on their content IDs. The add body part method adds a new MIME body part object to a MIME multipart as a step towards constructing a new multipart message. The MIME multipart class. The MIME multipart class extends multipart and models MIME multipart content within a message or body part. The class MIME multipart in package jakarta.mail.internet in module jakarta.mail. The MIME multipart class is an implementation of an abstract multipart class that uses MIME conventions for the multipart data. The MIME multipart class extends multipart and models MIME multipart content within a message or a body part. The MIME multipart is obtained from the MIME part containing a content type attribute set to multipart by invoking that part's getContent method. The client creates a new MIME multipart object by invoking its default constructor. To create new multipart MIME message, create a MIME multipart object or its subclass. Use set methods to fill the appropriate MIME body parts. And finally set content multipart to insert it into the MIME message. MIME multipart also provides the constructor that takes an input stream positioned at the beginning of MIME part stream. This class passes the input stream and creates a child body parts. The get subtype method returns the multi-part message MIME subtype. Subtype defines the relationship among the individual body parts of a multi-part message. More semantically complex multi-part subtypes are implemented as subclasses of multipart, providing additional methods that expose specific functionality. Note that the multipart content object is treated like any other content. When passing a MIME multipart stream, the Jakarta Mail implementation uses Jakarta Activation Framework to locate the suitable data content handler for a specific subtype and uses that handler to create appropriate multipart instance. Similarly, when generating the output stream for multipart object, the appropriate data handler is used to generate the stream. Now we are considering the MIME utility class. The MIME utility class is a utility class that provides MIME related functions. The class MIME utility in package jakarta.mail.internet in module jakarta.mail. This is a utility class that provides a various MIME related functionality. MIME utility is a utility class that provides MIME related functions. All methods in this class are static methods. These methods currently perform the functions listed below. Content encoding and decoding. Data sent over RFC 821 and 822 based mail systems are restricted to 7-bit US ASCII bytes. Therefore, any non-US ASCII content needs to be encoded into the 7-bit US ASCII mail safe format. MIME RFC 2045 specified the base 64 and quartet printable encoding schemes to perform this encoding. Following method supports content encoding. The get encoding method takes a data source object and returns the content transfer encoding that should apply to the data in that data source object to make it mail safe. The encode method wraps the encounter around the given output stream based on the specific content transfer encoding. The decode method decodes the given input stream based on the specific content transfer encoding. Header encoding and decoding. RFC 822 restricts the data message headers to 7-bit US ASCII characters. MIME RFC 2047 specifies the mechanism to encode non-7-bit US ASCII characters so that they are suitable for inclusion in message headers. This section describes the methods that enable this functionality. The header related methods getHeader and setHeader in part and message operate on strings. String object contains 16-bit Unicode characters. Since RFC 822 prohibits non-US ASCII characters in headers, client invoking setHeader methods must ensure that the header values are appropriately encoded if they contain US ASCII characters. The encoding process based on RFC 2047 consists of two steps. One, convert the Unicode string into an array of bytes in another char set. This step is required because Unicode is not yet widely used char set. Therefore, the client must convert the Unicode characters into a char set that is more palatable to the recipient. Apply a suitable encoding format that ensures the bytes obtained in the previous steps are mail safe. The encode text method combines the two steps listed above and to create the encoded header. Note that the RFC 2047 specifies only unstructured headers and user-defined extension headers to be encoded. It is prudent coding practice to run such header values through the encoder to be safe. Also note that the encode text method encodes header values only if they contain US ASCII characters. The reverse of this process, decoding, needs to be performed when handling header values obtained from MIME message or MIME body part using the getHeader set methods. Since these headers might be encoded as part of RFC 2047, the decode text makes header value applied RFC 2047 encoding standard and returns decoded value as a Unicode string. Note that this method should be invoked only on unstructured or user-defined headers. Also note that decode text attempt to decoding only if the header value is encoded in RFC 2047 style. It is advised that you always run header values through the decoder to be safe. Now we are considering the content type class. The following code fragments illustrate the use of this class to extract a MIME parameter. The class content type in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME content type value. It provides a method to pass the content type string into individual components and to generate MIME style content type strings. The content type class is a utility class that passes and generates MIME content headers. To pass MIME content value, create a content type object and invoke the toString method. The content type class also provides method that match your toString. The content type class also provides methods that match content type values. The following code fragment illustrate use of this class to extract MIME parameter. This code sample uses this class to construct MIME content type value. Now we are considering encrypted or sign in message security. The following code shows how might work. The non-GUI method of creating the message invokes using the multi-part encrypted sign classes. The class can be created and used as content for a message. Following code shows how it might work. The message will be encrypted when message is sent. There will be other methods that allow the setting of which encryption scheme shall be used and keys involved. Creating multi-part sign message is very similar to creating multi-part encrypted message, except that the multi-part sign object is created instead. You can set up a parameter for how you want to encrypt the message. Otherwise, it will use users preferences. Set the content you wish to encrypt multiple content as a multi-part mixed block should be used. An exception example, we can consider class pass exception. The exception thrown due to an error in passing RFC 822 or MIME headers including multi-part bodies. This class is in package jakarta.mail.internet. As an error example, we can consider this one, the property mail.mime.multipart.ignore missing end boundary is set to false. Normally, when passing a multipart MIME message, a message that is missing the final end boundary line is not considered as an error. The data simply ends at the end of the input. Note that messages of this form violate the MIME specification. If the property mail.mime.multipart.ignore missing end boundary is set to false, such messages are considered an error, and messaging exception will be thrown when passing such a message. The type of the property mail.mime.multipart.ignore missing boundary is Boolean.